It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now. It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
And battle
Hello everyone, good evening to all. So welcome to Unacademy, welcome to GATE Conqueror. Share the session guys, let's reach it to the maximum. Am I audible guys? Please confirm me, am I audible to you or not? Share the session guys. Suraj Padi, good evening. Saloni, good evening, right. So thanks for joining us today. So in this session, we are going to discuss about the problems on DC to DC converter. So be participative and be interactive in this session so that you will definitely get the best concepts of the DC to DC converter. Because so in a power electronics, in a GATE exam, we know that the weightage of power electronics is 8 to 10 marks. If you observe any previous year question paper, so before 10 years, so if you observe the previous year question papers, so 5 marks, you will get the 5 marks from the DC to DC converters. So this is DC to DC converters, that too. So when it is an operating continuous conduction mode, discontinuous conduction mode and boundary conduction mode, so it has more significance of this value. So the questions are coming from this area only. So then you will get definitely 5 marks. So if you solve all these problems, I will solve all the models in the DC to DC converters. So before that, let me So let me explain let me introduce myself. So I am Sathish Kumar Kesireddi. I got AR18 and AR286. So I had a 10 plus years of teaching experience. So I did my MTech in Power Electronics. So I did my MTech in Power Electronics in NIT Trichy. I was ex-BHL employee. So I was expertise in the subjects of Power Electronics, Power Systems and Network Theory. So here we have two types of subscriptions in the Unacademy. So one is plus subscription. So other one is the iconic subscription. In plus subscription, we have live classes, crash courses, weekly tests, doubt solving. The classes will be held in both English and Hindi. So in addition to all these features, so we have the additional features like in iconic subscription. So in iconic subscription, there will be the personal coach will be allotted. So he will be guide you like anything. There will be the personalized test analysis will be conducted here. Study booster sessions will be there. So dedicated doubt clearing instructor also will be there. So this is all additional features of the iconic subscription. So if you see the fee summary here, so that you can opt for the 12 months, 18 months and 24 months here. 12 months, 18 months and 24 months. If you use the code as KSK10, you will get the 10% discount. After 10% discount, this is the amount for the 12-month subscription. So here, if you are not able to bear the total amount, you can opt for the no cost EMI also. So this is the fee structure for the iconic subscription. So here we have the 12 months, 18 months and 24 months subscription. So here also you can opt for the no cost EMI. So if you use the code as KSK10, you will get the 10% discount. So this is the price hike. So here, so this is the offer, present offer is running on. So if you use the code as KSK10, you will get the 10% discount, right? But additional that, you have the additional 10% discount. So here, for the 10% discount, this will be the amount 29,205. So additional 10% discount you will get at the 26,285. So you'll get the additional 10% discount here. So offer alert, if you buy for the 6 months, you will get the additional 3 months of subscription. So from that you can save that 42% of amount. So the price hike will be coming soon. So hurry up guys. So this is Unacademy Ask a Doubt. So here you can ask for the unlimited doubt. So you can search for your exact matches. So there you can find that. There you can find the solutions for that. So you can find the quality solutions of both English and Hindi video solutions. You can find. So live mentoring product will be launched recently. So this is the 1:1 live mentoring product. Live mentoring with the new subscription. So with the new iconic subscription, you will get the 1:1 live mentoring. So this is the Arohan batch. This is for GATE and ESE. So 2023. So this is for electrical and it is for bilingual. The starting subjects will be network theory. So which will start from the 15th September. So this is the Arohan batch for ECE. So this is also bilingual. So both the classes will be held in both English and Hindi. So this is for ECE. So here the starting subjects will be the network theory. So this is the Valve batch. So for electrical. So the classes will be held in English. So the starting subject will be the control systems. This also start from 15th September. So this is the Valve batch for the GATE 2023. So this is also for English. So this is meant for English and this is for ECE. So the starting subject will be the control systems. So here also, so it will starting from the 15th September. So this is the Sathish Gate. If you want to follow me, so to attend the special classes, so this is the username of Sathish. This is the username of mine. So whenever I schedule the classes, you will get the notifications. So straight away, let us move to the session. Sharon Sai, good evening. Vamshi Krishna, good evening. Nagaraju, good evening. Harish 239. Right. Let us move into the session. So let us solve some conceptual questions. Thereby you will revise some of the theoretical concepts too. So here it is my first question. So So let me start with this question. So what is it? Let me explain the question first. The average input and output voltage of the converter is given. So that is Vs, that is input voltage is given as 120 volts and output voltage is given as 30 volts. So now, what could be the Chopper circuit and duty cycle? So they have given the inductor current waveform here. So for this inductor waveform, we need to find that. So this inductor waveform belongs to the which converter, and we need to find the duty cycle. So I think it was the easiest question. So try to find a solution for this. So try to find the solution for this. So try to find a solution for this. So here it was given as, so IL waveform has given. So IL is nothing but the current flowing through the inductance has given. So current flowing through the inductance has given. So which type of converter it is? Which type of converter it is? So here Vs is, so it will be the slope will be the Vs by L, and this slope will be given as Vs by L, and this slope will be given as V0 by L. So this slope will be given as V0 by L. So it is under the boundary conduction mode. This will be operating under the boundary conduction mode. If I draw the VL waveform, so that is voltage across inductance, during 0 to dt, the output voltage, the input voltage is Vs. So during the dt to t, the output voltage is given, which is the minus V0. This is the dt, and this will be the d dash t, where d dash equal to 1 minus d. So now let us find, so it is given as 120 volts, right? 120 volts, and it was given as minus 30. So it was given as minus 30. So minus V0, which is the 30 volts. So V0 is given as 30 volts, that is minus 30. So minus V0. So and if you observe this, so what is this converter? So this converter is belong to the buck boost converter. This converter belongs to the buck boost converter. How I am saying? So let me draw the buck boost converter. If I draw the buck boost converter, so the circuit would be like this. The inductor is common to both source and load. So the inductor is common to both source and load. If I find the VL during the on period of one switch, so what is the VL here? If I close the switch to here, so what is the VL? So VL equal to Vs. So during this period, VL equal to Vs. For example, if I move the switch to the different position, so what is the VL here? So VL equal to, so minus V0. VL equal to minus V0. So VL equal to minus V0. So which is the, so VL equal to V0 equal given as, so 30 volts, Vs is given as 120 volts. And it is related to the buck boost converter. So here one option is there for the buck boost converter, so option C. So here we need to find the duty cycle too. How I can find? So I know that for the buck boost converter, so the gain will be, for the buck boost converter, the gain will be V0 by Vs equal to, right? V0 by Vs equal to d by 1 minus d. So V0 value I got as 120 volts. And the Vs is 30 volts, right? Vs is 30 volts. So Vs is 30 volts, which is equal to d by 1 minus d. So from this, if I find that, I will get the d equal to 0.2. Now option C is the right option. Let us see how many of you answered correctly. So right, option C is the right option. Madhuvan Prajapati, right? Option C is the right option. So let us see the next problem. So this converter has given, so which is the buck converter has given. So in this circuit it was given as buck converter. Let me explain the problem first. So the Vs is given as 40 volts. Right? So R value is given as 10 ohms. Resistance value is given as 10 ohms. Right? So duty cycle is given as 0.5. And V0 is given as 25 volts. So frequency is 10 kilohertz. So this is the data they have given. So what they have asking, find the operating mode, which operating mode it is operating, and the value of inductance. So here in this case, we need to find so the operating mode, in which operating mode it is operating, as well as we need to find the value of inductance. L. So let us find. So first of all, so which operating mode it is? Can anyone tell? So which operating mode it is? Yes, Mohan. So in the coming problem, we have the one cascaded connection. Let me explain there. We have different problem sets here. I will cover all the concepts which are exist in the DC to DC converters. So whether it is operating in discontinuous conduction mode or continuous conduction mode, how I can find? Let us see. For example, if I find the output voltage in case of continuous conduction mode, what happens? So if I want to find the output voltage in the continuous conduction mode, so what is the expression for this? So we know that voltage gain is the duty cycle. Duty cycle into input voltage. For the continuous conduction mode, for example, if I assume that it is a continuous conduction mode, so it will be the duty cycle. 40 into 0.5. So which is the 20 volts. But, so what is the output voltage has given here? So in the problem, the output voltage is given as 25 volts. So V0 is given as 25 volts. So if you observe this, the V0 of given value is greater than the continuous conduction mode. From this we can conclude that, so we know that V0 of discontinuous conduction mode is greater than V0 of continuous conduction mode. So from this we can derive that, so it is operating in the discontinuous conduction mode. Let me be more clear. So V0 is discontinuous mode has given, so it will be the 25 volts. So from this expression we are concluded that it is operating in the discontinuous conduction mode. But if you observe in the problem, so there will be the two options are there. So B and C are the correct options. Up to here, B and C are the correct options. So next what we need to find? So we need to find the inductance. Hari 239, just check once again. So it will be the discontinuous conduction mode. Now we need to find the inductance value. How we can find the inductance value? Let us see how we can find the inductance value for this. So as we know that from the basic concepts only, let us derive the output voltage, that is inductance. So how we can derive? Let us see. So for example, if I draw the IL waveform for this, if you understand the concept, it is easy. No need to remember any of the formula. So the IL waveform would be, because it is operating in the discontinuous conduction mode, the IL waveform would be like this, right? The IL waveform is like this. If I draw the VL waveform, so the VL waveform will be 0 to dt, it will be the during the dt period, and this will be the d1t period, and this is the total time period. Let it be the dt, d1t and total time period. If I draw the VL waveform, so VL equal to, for the buck converter, it will be the, when S is in on condition, so during this period switch is in on condition, during this period diode is in on condition. Right? So now, so what we have to find? It will be the Vs minus V0, and it will be the minus V0. So it will be the minus V0. If you know this, that is sufficient. So this you can get from the basic concepts. If you know the buck converter, you can get from the basic concepts. So now let us find the so here Vs minus V0. So what is the Vs minus V0? So Vs is given as 40 and V0 is given as 25. So which is equal to 15. So which is equal to 15 volts. So what is the V0 value? So V0 is given as 25. So V0 is given as 25. So this period will be the dt and this period will be the d1t. Try to find d1 value. How we can find the d1 value? Let us see here. Try to find the d1 value. How I can find? So 15 into d into t, that is duty cycle into t, right? 15 into dt minus 25 into d1t. So which is equal to 0. So from this I can find the d1 value. So because the duty cycle is given as 0.5. So 15 into 0.5 minus 25 into d1. So which is equal to 0. So d1 equal to, so what is the value of d1? Let me find the d1. So 15 into 0.5, 7.5 divided by 25. So d1, I will get the d1 as 0.3. First, we need to find the D1 value. To find the inductance, we need to find the D1 value. So now we got the D1 value. We got the D1 value. So now what we have to find? So we need to find L value, inductance value. So let us see how we can find the inductance value from this. So here, so in case of buck converter, we know that in case of buck converter, so we know that IL equal to I naught. We know that IL equal to I naught. So the average value of IL equal to I naught. So how I can find the average value? So it is simple. So let it be the I max. Let it be the I max. How I can find? I need to find the total area with respect to time. So IL average equal to from this how I can find 1 by 2 into, it is a triangle, right? 1 by 2 into I max into D1T into, so D plus D1T plus D1 into T, so divided by time period. This is the average value, right? This is the average value. So I'm revising the basic concepts. So if you know the concept directly, you can write. So how I can find the I max? So I max will be this depends on slope. So which is nothing but Vs minus V naught by L. Vs minus V naught by L. So I max equal to Vs minus V naught by L into dt. Vs minus V naught by L into d into t. So where t equal to 1 by f. If I substitute all this, I can get the value. So half into 1 by 2 into I max equal to Vs minus V naught. What is the Vs value here? So Vs is 40 and V naught is minus 25. So divided by L into F. L into duty cycle is given as 0.5. So what is the frequency they have given? So the frequency is given as 10 kHz. Right? So from this we have got this expression. So into D plus D1. So into D plus D1. In this T and T will get cancelled out. Into D plus D1. So which is nothing but 0.5 plus 0.3. So we got the IL waveform, which is equal to I naught. I naught equal to V naught by R. So V naught equal to given as 25 volts. And what is the R value we have? So let us see what is the R value. So the R value is given as, 10 ohms. R value is given as 10 ohms. So if I substitute R value is 10 ohms, so here in this total expression, if you observe this, so we don't know the L value. Remaining all values we know that. So if you find this L equal to 0.12 millihenry, you will get the 0.12 millihenry. You will get the answer as 0.12 millihenry. This we have derived from the basic concept. So the option B is the right option. So efficiency, right? Efficiency can be calculated by the Binod Gimre. So efficiency can be calculated by the P naught by Pn, right? That's we know that. So V naught into I naught divided by V in into I in. So I naught can be determined. So input source current should be determined here. Source current should be, so find here. In this case, it should be source current will be different. Surajpadi, it will be the 0.12 millihenry. Let us check again. So it will be the 0.12 millihenry. 0.12 millihenry it will be. Check answer again. So but it is very easy if you know the concept. So the discontinuous mode problem, many of the students facing that. So the problem with the discontinuous conduction mode. But if you know the basic concept, that is sufficient to solve any of the problem. If I take the buck converter, there I need to take the IL equal to I naught. If I take the boost and buck boost converter, I need to take the relation as ID equal to I naught. So from this we can find. The answer would be the 0.12 millihenry and it is operating in the DC discontinuous conduction mode. Check once again. So you need to get the procedure first. You need to understand the procedure first. If you understand the procedure, that is sufficient. So this is how we solve the problem. First we need to find whether it is operating in the continuous conduction mode or discontinuous conduction mode. So we have found that, so it is operating in the discontinuous conduction mode. Why? Because V naught of discontinuous conduction mode is greater than the V naught of continuous conduction mode. So if you take the two expressions, from that also you can compare, you will get the V naught of discontinuous conduction mode more than the V naught of continuous conduction mode. So from that we have find that, so it is operating in the discontinuous conduction mode. So after that we need to find the inductance value. For that what I have taken, so the relation of IL equal to I naught. The relation IL equal to I naught. If relation of IL equal to I naught, so I need to find the IL average. So from where I need to find the IL average? So from this waveform. So I need to find the IL average. So I have find the IL average, right? So I have find the IL average. So from that I have find the inductance value. So because the inductance only the unknown parameters in this expression. Right. Let us see the one more problem. Right. So let us see the one more problem. Mohan Moki, here you will get the answer for your question. Here you will get the answer for this question. Let us see. So I can explain this question. So what is this question? Let me explain the question first. So it was given as cascaded connection of buck converter. So it was given as cascaded connection of buck converter and the boost converter. So cascaded connection of buck and boost converter. So as shown in the figure, with the duty cycle D equal to 0.4. So it has the common duty cycle, so which is having the D equal to 0.4. Now D equal to 0.4. So Vs equal to 20 volts. Now we need to find the output voltage here. How I can find the output voltage? So which is easiest question? Try to find the output voltage of this one. Try to find the output voltage for this one. So how we can find the output voltage? So what is the expression for output voltage? Let me explain the question clearly. So here the starting converter will be the buck converter. We know that in the buck converter the circuit would be like this. So the inductance on the load side, right? The circuit will be like this for the buck converter. So it is a buck converter. So for this buck converter, we have connected the one more converter. So which is the boost converter. Right? So this is the circuit they have given. So they are connected in the cascaded connection. Here they are connected in the cascaded connection. Let me assume this voltage as V1. So how this voltage is V0? Let me assume this voltage is V0 and this is the Vs. So what we have to find? We need to find the output voltage. So V0 by Vs we need to find. If I know the V0 by Vs value, gain value, I can find the. So if I know the V0 by Vs, I can find the V0 easily. How I can find? Let us see. For example, if I find the gain of this converter. So what is the gain of this converter? So input voltage is Vs. So output voltage is V1. Let me find the gain of the first converter. Let me call it as M of D1. So for the first converter, so what is the gain here? So which is V1 by Vs. So what is the second converter gain? So here the second converter gain will be V0 by V1, right? M of D2 equal to V0 by V1. So this is the gain of the second converter. Now I want to find the total gain. How I can find? So total gain equal to V0 by Vs equal to if I multiply both of these, so I will get the same value. So which is a V1 by Vs into V0 by V1. So that means if I multiply the gain of the two converters, I will get the total gain. So M of D1 into M of D2. So when the two converters are connected in the cascaded connection, if you multiply the both of the gains, two gains, you will get the overall gain. So what is the buck converter gain? So what is the gain of buck converter? So we know that gain of buck converter will be M of D1 will be duty cycle D, right? So what is the gain of the boost converter? So it will be the 1 by 1 minus D. So 1 by 1 minus D. 1 by 1 minus d. So now I need to find the V0 value. Now I need to find the V0 value. So how I can find? So Vs into d by 1 minus d. So Vs is given as 20 volts. Duty cycle is given as 0.4 divided by 1 minus 0.4. 1 minus 0.4. So let me find this. So 20 into 0.4 divided by 1 minus 0.4. So it will be the 13.33 volts. The answer will be 13.33 volts. Let me see how many members have answered correctly. So 13.33 volts. The answer would be the 13.33 volts. 13.33 volts. So let us see. So how many members have answered correctly? Yeah, Surajpati, you are right. Output of 1 is input to the second. The answer is 13.33 volts. Saloni, you are right. Mohan Moki, right. I think you have understood now. Mohan, I think you have understood now. So the cascaded connection is nothing but you need to multiply the gain of the two converters. You need to multiply the gain of two converters. You need to multiply the gain of two converters. So let us solve the next question. Can anyone tell which kind of operation it is? So can anyone tell which kind of operation it is? So can anyone tell which kind of operation it is? So Mohan Moki, that will be the different scenario. So it is not belongs to the cascaded connection. So if the cascaded connection with the different duty cycles, so we will get the different. So it will be the different analysis. There we need to find the voltage across inductance. From that only we can find. So can anyone tell which kind of operation it is? So here the converter is given. Let me explain what it is. So here the converter is given. So it is the boost converter. So it delivers power to the load. It is delivering power to the load. So with the inductor voltage waveform has given. So directly they have given the inductor voltage waveform. So inductor voltage waveform has given. So now R is given as 10 ohms. Resistance is given as 10 ohms. And determine the operating mode and the inductance. Determine the operating mode and the value of inductance. So which kind of operation it will be? So by observing the waveform itself, we can tell that. So Harish 239, very good. It will be the DCM. So DCM, why? Because, so it will be the DCM, why? Because, so if you observe the circuit, if I draw the inductor current for this, so how the inductor current would be? If I draw the inductor current for this, so because it is a boost converter, so it was given as boost converter, right? So it was given as a boost converter. If I draw the inductor current, how the inductor current would be? 0 to dt, that is 0 to 0.4 milliseconds. So it will be in the, so Vs, so it will be the Vs, right? It will be the Vs by L, right? So now, so after that 0.4 to 1.2 milliseconds, 0.4 to 1.2 millisecond, it will be the Vs minus V0 by L. So Vs minus V0 by L. Now this portion will be the same. So if you observe this, by observing the inductor waveform, we can tell this. So we can tell this it is operating in the discontinuous conduction mode. Now what we have to find? So now the first one is clear, it is operating in the discontinuous conduction mode. So again we need to find the inductance here. How we can find? Let us see. So now let me find the D and D1. So what is the total time period here? From this graph, what is the total time period? Total time period is given as 2 milliseconds. So what is the time period of dt? So dt is given as, d into t is given as, so 0.4 milliseconds. So 0.4 milliseconds. So what is the d1t? So remaining time period. So what is the d1t here? So d1t is the, so from here to here. So which is the 0.8 milliseconds. 8 milliseconds. So now, so what is the d1t? d1 into t equal to 0.8 milliseconds. If I know the t value, if I know the dt value, if I know the d1t value, can I find? So can I find, let it be the d1t. So this portion will be the d1t and this will be the dt. This will be the dt. So I can find the d and d1 easily, right? I can find the d1, d1. D and d1. How I can find? So d equal to, let me find the d value. So d equal to, so t value is given as 2 milliseconds, 0.4 by 2 milliseconds, dt is 0.4, so dt by t equal to d, so which is equal to 0.2. I will get the d equal to 0.2. So what is the d1 value? 0.8 divided by 2, so which is the d1 equal to 0.8 divided by 2, which is the 0.4. So which is the divided by 0.4. Now we got the d value as 0.2 and d1 value as the 0.4. So now what we have to find? We need to find the inductance. How I can find the inductance? In case of boost converter, so in case of boost converter, if I draw the boost converter, for example, if I draw the boost converter, how it would be? So the inductor on source side, so the voltage source will be here, so the circuit will be, so here the switch will be there, and here the diode is there, capacitance and the resistance. Capacitance and resistance. If I want to find the I0, so how I can find? ID equal to IC plus I0. ID equal to IC plus I0. So if I want to find the ID value, average value of ID equal to I0. Average value of ID equal to I0. So that we need to find the average value of ID here. So if you observe here, ID equal to IC plus I0, the average value of the capacitor current equals 0, so that average value of ID equal to I0. So now we know that I0 equal to V0 by R. But so we don't know the ID value. We need to find the ID value. How I can find? Let me find the ID value. Let me find the ID value here. How I can find? Let us see. So how I can find the ID value? So the ID value is nothing but, so this portion, the diode will conduct for only the d1t period. If I draw the diode current, here, the diode current will exist only during this period. So now I need to find that area. So if I find that area, the problem has solved. So the diode current average value equal to, half into Imax into d1t divided by time period. So this is the average value. If time period will get cancelled out, so it will be the half into Imax into d1. So now how we can find the Imax? So this slope will be the Vs by L. By substituting the Vs by L into dt, I can find. So now let me substitute this. So 1 by 2 into Vs by L. So Vs is given as, so Vs, we got the Vs as, so Vs is 40 volts. So Vs is 40 volts. Vs by L into, so d1, so into d1t, so it will be the dt. So this Imax can be determined from, so this line equation. If the slope is Vs by L, I can find the Imax value. Imax is nothing but this y-axis. So what is the slope of this line? Imax by dt. So what is this value? Vs by L. So which is equal to Vs by L into d into t. Right? Vs by L into d into t. So into d1. So we know all these values. What is the dt value? Dt is equal to 0.4 milliseconds. So now ID equal to half into 40 by L into dt is given as 0.4 milliseconds, and d1 we got as 0.4. So d1 we got as 0.4. So what is the V0 here? So if Vs minus V0 equal to minus 20, Vs minus V0 equal to minus 20. So if Vs minus V0 equal to minus 20, Vs minus V0 equal to minus 20, and Vs equal to 40. If Vs equal to 40, so what is the V0 value? So if I substitute Vs here, I will get the V0 as 60 volts. V0 as 60 volts. And R is given as 10 ohms. If I make this equal to V0 by R, so V0 equals 60 volts and R equal 10 ohms. I will get the L value. Only the L is the unknown parameter here. So now we can find the L value. So So the answer would be, so for this question, the answer would be the 0.533, so millihenries, 0.533 millihenries. So this is how we will find the IL value. This is how we will find the inductance value. This is how we will find the inductance value. So what we have done here, in case of buck converter, we have used the relation as IL equal to I naught. So in case of boost converter, so we have used the relation of ID equal to I naught. ID equal to I naught. So for this, we know just minimum basics we need. So if you know that basics, so directly you can find the inductance value. So now the option, so it will be operating in the discontinuous conduction mode. So it will be the 0.533 millihenry. So it will be the 0.533 millihenry. Here we need to find the Imax value. So for the line, for the simple line, you can find the maximum value that is sufficient. So from the basic concepts only, so we have derived the problem. Not 60, it will be the 0.533 millihenry. 0.533 millihenry. So this is how we will solve the problem. This is how we will solve the problem. So just we will use the basic concepts. So that's why you need to remember the procedure. No need to buy out any of the formula of the discontinuous conduction mode. If you know the basic concept, that is sufficient. If you know the basic concept, that is sufficient. So if you know the basic concept, that is sufficient. So to find the L value here, let us see. Let us see the next question. So this is easiest question. This is easiest question. Try to find the input resistance. Here the converter is given as buck boost converter. Here the converter is given as buck boost converter. And switch is operating at 25 kHz and duty ratio is given as 0.75. So under steady state condition, determine the R in value. So we need to find the input resistance value. Input resistance value. Find the R in value seen by the source. So try to find this question. Try to find this question. Share the session, guys. Share the session. Share the session, guys. Saloni, if you remember the process, so which is easy. If you remember the formula, so if they ask for different parameters, it will be difficult. It will be difficult. So no need to remember the process. No need to remember the process, but observe that ID should be equal to I naught. So in case of boost converter, in case of buck boost converter, so ID should be equal to I naught. That is simple basic derivation. From the basic concepts only we have derived. But if you apply the formula, it will be difficult for you. Definitely it will be difficult for you. There you have to remember lot of formulas. Because once non-ideality is also added, so it will be difficult to understand remember the formulas. Let us solve the next question. Let us solve the next question. So what is the input resistance here? So what is the input resistance here? Try to find the input resistance. Try to find the input resistance here. Try to find the input resistance. How I can find? So the finding the input resistance is as simple as, so if you know the DC transformer model, if you know the DC transformer equivalent circuit, if you know the DC transformer equivalent circuit, so it will be very easy to find the input resistance. It will be very easy to find input resistance. How we can find? Let us see. So the R value is given as R naught value, that is load resistance value is given as 10 ohms. R naught or RL value is given as 10 ohms. Is given as 10 ohms. So now, so it is operating in the continuous conduction mode. So try to find this one. So what is the value here? Try to find the R in value here, input resistance. How we can find? Let us see. If I take the DC transformer model, so already we have discussed, if I take the DC transformer model, so M of D for the buck boost converter will be, so the gain of the converter for the buck boost converter will be D by 1 minus D, right? So it will be the 1:m of D is the ratio. If I want to shift this output resistance to the input resistance, if I want to shift this output resistance to the input resistance, I need to divide with the transformation ratio square. So R input equal to R naught divided by m of D whole square. Make it as a shortcut for you. So use it as a shortcut like that. So R naught divided by m of D whole square. What is m of D here? So m of D is nothing but voltage gain of the converter. So this voltage gain will be, so D for the buck converter. So D for the buck converter, 1 by 1 minus D for the boost converter, D by 1 minus D for the buck boost converter. So if you observe here, so here it is the buck boost converter. So if I can find the m of D, so I can find answer easily. So how I can find m of D? So m of D equal to, it is a buck boost converter, it is a D by 1 minus D, D by 1 minus. So what is the D value they have given? 0.75 divided by, so 1 minus 0.75 divided by 1 minus 0.75. So what is the answer for this? So 0.75 divided by 0.25. So it will be the 3. M of D will get the 3. M of D will get the 3. So now we need to find the input resistance. So how I can find? So the input resistance equal to output resistance divided by m of D whole square. M of D whole square is nothing but 3 square. So 10 by 3 square. So the answer would be the 10 by 3 square. So it will be the 1.111 ohms. So the answer will be the 1.11 ohms. So the answer would be the 1.11 ohms. Surajpati, you're right, 1.11 ohms. Saloni, right. So 1.11 ohms. Right, Harish, very good. So 1.11 ohms. So it is simple, guys. Make it as a shortcut. So if they are given any of the problem, within seconds you can write the answer. If you know the R naught value, R naught equal to R in equal to R naught by m of D whole square, where m of D is the voltage gain of the converter. So it is D for the buck converter. It is 1 by 1 minus D for the boost converter. It is D by 1 minus D for the buck boost converter. So whichever be the converter here, if the converter has changed, even if the converter has changed, no need to worry. So directly you can find if you know the R naught value. Let us see the next problem. Let us solve the next problem. So which is easiest question, guys? So I think in this problem, in all these problems, which is the easiest question? So try to find a solution for this. Try to find the solution for this. So what they have given? So VDC equal 20 volts. So here VDC is given as 20 volts. So the switch is operated at the duty cycle 0.5. Duty cycle is 0.5. A large capacitor is connected across the load and the inductor current is assumed to the continuous. So inductor current is continuous in the sense. So this converter is operating in the continuous conduction mode. This converter is operating in the continuous conduction mode. So IL is given as average value of the inductor current is 4 amperes. IL equal to 4 amperes. So now what we have to find here? So what we have to find? So we need to find the average voltage across the load. So V0 as well as ID average value we need to find. ID average value we need to find. So this is the question they have given. Nowhere they have mentioned that which type of converter it is. But by observing the circuit, we can find that which type of converter. So which type of converter here? So because inductance is placed on source side, so simply we can say that, so it is a boost converter. It is a boost converter. If the inductor is placed on load side, it will be the buck converter. If the inductor is placed on both source and between the both source and load, it will be the buck boost converter. So we are clear, it was the boost converter. Now we are clear with it is a boost converter. Now what we have to find? So we need to find the output voltage. Simple question, very simple question. So what is output voltage? So very simple question, guys, it is. So output voltage V0 equal to, so what is the output voltage? So which is input voltage into VDC into 1 by 1 minus D. 1 by 1 minus D. So here the duty cycle has given us 0.5. Duty cycle has given us 0.5. So the input voltage is, given as, so what is the input voltage is 20 volts. So 20 divided by 1 minus 0.5. So which is the 40 volts. Right, which is very easy, right? So the gain of the boost converter will be the 1 by 1 minus D. Now we need to find the average value of the diode current. average value of the diode current. How I can find the average value of the diode current? So simple, it is also simple. So from the fundamental concepts only, let us find from the fundamental concepts. So during the DT period, what happens? During the DT period, this switch will be in the on condition. During the DT period, this switch will be in the on condition. During the 1 minus D into T period, during the D dash T period, so 1 minus D into T period, this diode will be in the on condition. So what we have to observe? So if you observe here, this inductor current flows during only the period of 1 minus D into T. So directly we can write that IL equal to ID equal to IL into 1 minus D. IL into 1 minus D. So IL into 1 minus D. ID equal to IL into 1 minus. For example, if they ask for the switch current, how we can find? So which is the IL into duty cycle. So here we need to take the IL into 1 minus D. Now let us find IL into 1 minus D here. So how we can find? It is easy. So IL is given as 4 amperes and the duty cycle is given as 0.5, 1 minus 0.5. So which is the 2 amperes? Which is the 2 amperes. So the answer would be the 40 volts and 2 amperes. Option C is the right option. Option C is the right option. Right. So right. Harish, you're right. Surajpati, right. So be interactive, guys. Here we are discussing more conceptual questions. So only from the basic concepts only, let us derive the problems. Let us solve the problems. No need to remember all the formulas, no need to mug up all the formulas on there. So find this. So you will get the 40 volts and 2 amperes. So I think everyone is clear. So let us move to the next problem. So this is also very easy problem. If you know the basic concept. Here also no need to buy out the formulas and everything. Just concentrate on the converter topology. So understand the concept. Right. Nagaraju, right answer. C is the right answer. C is the right answer, guys. So now let us solve the next question here. So what is the question here? So let me explain the question first. So what is the question here? So if you observe the question, so be interactive, guys. Be interactive. If you have any doubt, you can stop at any point, you can ask. So be interactive, but be interactive. So here it will be the operating at 10 kHz. The frequency is given as 10 kHz. So now, if the switch is placed in 1, so the inductor stores some energy. So in the period of 50 microseconds. So that on time of the switch is given as, when it is in position 1, so it was given as 50 microseconds. So during that inductor release the energy. So when it is moved to the position 2, so T, that will be the 20 microseconds. Now what they have asked? So they have asked for the total release energy in the 20 microseconds. So total and releases the energy in the 20 microseconds and it will be the 50 microseconds. The switch is moved to the position 2. Find the V1 by V2. We need to find the V1 by V2. So what is the V1 by V2? So try to find the V1 by V2. So be interactive. If you have any doubt, you can stop anywhere. You can stop at any point, you can ask, guys. So try to find the V1 by V2. So here it is, my first question is, so in which operating mode this converter is operating? Can anyone tell which operating mode this converter is operating? In which operating mode this converter is operating? Operating mode of converter. So what is the operating mode of converter? So before solving the question, so try to understand this one. What is the operating mode of converter? Let us see, Harish. So now let's answer this question. So what is the operating mode of this converter? Can anyone tell what is the operating mode of this converter? So what is the operating mode of this converter? So which is very easy question, guys. Very simple question. So by simply observing, we can tell the answer. But so what is the operating mode of this converter? Can anyone tell? Sahicha, right, you're right. It is operating in discontinuous conduction mode. So how we have told that it is operating in the discontinuous conduction mode? Let us see. So now, let us see. So what is the total time period here? So the total time period will be the 1 by 10 kilohertz, 1 by 10 kilohertz, which is equal to 100 microseconds. The total time period is 100 microseconds. The total time period is 100 microseconds. How I can find? Let me draw the VL waveform for this. Let me draw the VL waveform. When it is in position 1, what happens? The inductor stores the energy for the period of 50 microseconds. So now, during that time, what is the inductor voltage? If this is closer to the switch 1, so what is the inductance voltage? VL equal to V1. VL equal to V1. During the 50 microseconds, it will be the V1. So it will be the V1. So during the 50 microseconds, it will be the V1. 50 microseconds, it will be the V1. So during the next period, so during the 20 microseconds, what we are doing? So during the 20 microseconds, we are shifting this switch to the position 1 to the position 2. Let me move this switch to the position 2. So what is the VL? So VL equal to minus V2. VL equal to minus V2. So VL equal to minus V2 during the period of 20 microseconds. 20 microseconds. So minus V2. So by observing this waveform, I can tell that it is operating in the discontinuous conduction mode. Those who tell the discontinuous conduction mode, it was good. So you are good. So now, so by observing this waveform, so we can tell that it is operating in the discontinuous conduction mode. Is there any formula is needed to solve this? No, not at all. So observe this. So we know that volt-second balance. If you know the volt-second balance concept, that is sufficient. If anyone is asking for voltage gain, in any problem, they have asked for the voltage gain, try to find the volt-second balance. Try to obtain the inductor voltage waveform, from that apply the volt-second balance. If I apply the volt-second balance, how it would be? So V1 into 50 microseconds, right? V1 into 50 microseconds minus V2 into 20 microseconds. 20 microseconds. So it should be equal to 0. The average area across the inductance should be equal to 0. If I find the area of these two, so it will be 0, right? So from this I can find, so V1 into 50, V1 into 5 equal to, so V1 into 5 equal to, V1 into 5 equal to V2 into 2. V2 into 2. So now tell me, what is the V1 by V2? So V1 by V2 equal to 2 by 5. So very simple question. V1 by V2 equal to 2 by 5. Just we need the basic concept, that's it. We need if you know the basic concept, that is sufficient. So the answer A is the right option. Answer A is the right option. Yeah, Surajpadi, A is the right option. Right, Saloni, right, A is the right option. A is the right option. A is the right option. Guys, A is the right option. So now we are clear with this concept, right? So I told that it is operating in the discontinuous conduction mode. So if they asked for the V1 by V2, so we need to apply the volt-second balance. That's it. So for volt-second balance, we need to draw the VL waveform. So if I draw the VL waveform, so it will be, so within seconds you can solve. By observing the circuit also you can tell that. Let us solve the next question, guys. If you have any doubt, you can ask. So till now, if you have any doubt, you can ask. So let us solve the next question. Let us solve the next question. So here, so let me explain the question first. What is the question here? So the ideal switch is S, switched on and off. So this converter will be the buck boost converter, that is clear. So now the switching frequency is given as 10 kHz. And so the switching time period will be the 100 microseconds. So 1 by 10 kHz is the 100 microseconds. The circuit is opened, so in boundary continuous conduction mode, boundary between the continuous and discontinuous conduction mode. So which type of conduction mode will be in the, so from the problem itself they have told that it is operating in the boundary conduction mode. That is in between the, it is just continuous. So now it is a boundary conduction mode. So it is boundary conduction mode. That's, we are clear with this. Now what we need to find? Find the on time of the switch. How much time the switch has on in microseconds. So the second value is the value of the peak current in amperes. So we need to find the value of the peak current as well as we need to find the value of peak current as well as, so we need to find the switch on time. We need to find the switch on time. So for this, let me draw the IL waveform. For this, let me draw the IL waveform. So if I draw the IL waveform, how the IL waveform? So it is a buck boost converter, right? It is a buck boost converter and it is operating in the boundary conduction mode. So we know that the boundary conduction mode waveform would be like this. Boundary conduction mode waveform would be like this. So this period will be the dt, right? This period will be the dt, that is on time of the switch, and this period will be the d dash t, that is off time of the switch, right? So this slope will be the Vs by L, this slope will be the Vs by L, and this slope will be the V0 by L. This slope will be the V0 by L. So Vs is given as 100, Vs is given as 100, and V2 is given as, so if I draw the VL waveform, so if I draw the VL waveform, how the VL waveform would be? So the VL waveform would be like this. If I draw the VL waveform, so the VL waveform would be like this. So when switch is in on condition, so the VL equal to Vs, when switch is in off condition, that is, so when diode is in on condition, VL equal to minus V2. So what is the Vs value? Vs value here, so which is 100, right? Which is 100 volts, and which is the minus 500 volts. If I know this, I can find the T on time. So I can find the T on time. So how I can find? So I need to find the duty cycle. So after that I need to multiply with the T. So I will get the T on time. So how it will be? Let us see. So it will be the 100 into, so integration of VL dt equal to 0. If I find the integration of VL dt, it will be 0. So 100 into dt, so 100 into dt, right? 100 into dt minus 500 into 1 minus d into t. 1 minus d into t. So which is equal to 0. Which is equal to 0. So if I find this, so 100 into d minus 500, right? Plus 500d equal to 0. Plus 500d equal to 0. So now if I substitute, so what is the d value here? So what is the d value here? So let us find the d value. So d value would be the, so 5 by 6. D value would be the 5 by 6. So which is a 0.833. 0.833. So now we got the duty cycle as 0.88. Harish 239, you are asking for previous problem or what? Let's try to find the duty cycle. 0.833. 0.833 is the duty cycle. Now try to find, so now we got the duty cycle as 0.833. Turn on time. What is turn on time here? So T on equal to D into T. T on equal to D into T. So on time of the switch equal to T into D into T. So which is equal to, what is the D into T here? So which is equal to 83 point, so where T equal to 100 microseconds, if I multiply this one, so I will get the 83.33 microseconds. So T on period is the D into T, because switch is on for the period of D into T. So we know the total time period is given as 100 microseconds, duty cycle we got as 0.833. So now we got the first answer as 83.3 microseconds. Now let us find peak value. So the maximum value we need to find. This maximum value we need to find. So maximum value of the switch current is nothing but maximum value of the inductor current. So both are same, because during the DT period, so if the switch current will be, so only during this period only the switch will in the conduction state. If you observe that the Imax will be same for the inductor current as well as switch current. Now if I find the Imax from this, so Imax by dt equal to Vs by L. The slope will be the Vs by L. So Vs by L into dt. Vs by L into dt. So the Vs is 100 volts. Vs is 100 volts, right? Vs equal to 100 volts. So the L value is 100 microhenry. L value is 100 microhenry. So we got the dt as 83.33. We got the dt as 83.33 micro. So the current will be the 83.3 amperes. 83.3 amperes. So the current will be the 83.3 amperes. So this answer will be the 83.33 amperes. So the peak value of the current is equal to the peak value of the switch current in this case. So because if I draw the switch current, so it would be like this. If I draw the switch current, it would be like this. If I draw the switch current, it would be like this. So maximum value will be found from the simple line equation. I know the slope as Vs by L, right? So I know the line, so it has the maximum value as y point and dt is the x point, right? So I can find easily, So this is 83.3 amperes. Yes, you need to practice, Suraj, you need to practice. So you need to revise the basic concepts. Just we are revising the basic concepts what we have learned. Just revise the basic concepts. Just again you observe all these questions and find by yourself and revise the basic concepts so that you can understand. Very easy question. These questions, all questions are very easy questions. Now let us see the next question. Here it is the question, guys. Here it is the question. So let me explain what is the question here. Try to find the solution for this. So try to find the solution for this question. So this is the circuit has given and V1 and V2 has given. What we have to find? So the V1 is given as 100 volts. The V1 is given as 100 volts and V2 is given as 300 volts. V1 is given as 100 volts, V2 is given as 300 volts and duty cycle is given as 0.5. So frequency is given as 20 kilohertz. Try to find the solution for this. So we need to find power transferred from the DC voltage source to the DC voltage source V2. So from V1 to V2 how much power is transferring we need to find. So from the V1 to V2 how much power is transferring we need to find. So here it is, my first question is, so in which operating mode, so this converter is operating. So the operating mode of converter. So for any problem, first we should investigate that. So in which operating mode it is operating? In which operating mode it is operating? So in which operating mode it is operating? Can anyone tell? So in which operating mode it is operating? So be interactive, guys. Can anyone tell in which operating mode it is operating? Ask questions, guys. If you have any doubt, you can ask questions. So even for the simple questions also you can ask. So no need to worry. So clear all your doubts. We need to find operating mode. In which operating mode it is operating? So Harish 239. Good, very good. So now, how we are saying that? So it is operating in the discontinuous conduction mode. So whatever Harish is said, it is right, which is operating in the discontinuous conduction mode. So why it is operating in the discontinuous conduction mode? Let us see. So the input voltage V1 is given as 100 volts. V1 is given as 100 volts. And V2 is given as 300 volts. And the duty cycle is given as 0.5. Now, if I find the output voltage of boost converter for the continuous conduction mode, how I can find? So output voltage of the converter. So output voltage is nothing but V2. So which is equal to V1 into 1 by 1 minus D. So for the continuous conduction mode. If I find output voltage for the continuous conduction mode, it will be the 100 by 0.5. So which is equal to 200 volts. So 100 by 0.5. So we will get the 200 volts. But what is the V2 has given? So V2 is given as 300 volts. Here V2 is given as 300 volts. And V1, we got the V2 for the continuous conduction mode, we got the 200 volts. But given voltage is greater than the continuous conduction mode voltage. So that is, it is operating in the discontinuous conduction mode. So we are clear. So it is operating in discontinuous conduction mode. Next, what we need to find? we need to find the power. We need to find the power. So which power? The power is delivering from the power is delivering from the source to the load. So here one more source will be there. So this source to this source. How I can find? So how I can find for this? So I need to find for this. How I can find? So I can find. So by drawing the IL and VL waveform, so easily I can find. So let me draw the IL and VL waveform. Let me draw the IL and VL waveform for this. So how I can draw the IL and VL waveform? Let us see. So if I draw the IL waveform, so the IL waveform would be like this. If I draw the IL waveform, so IL waveform would be, so it is a boost converter, right? It is operating in the discontinuous conduction mode. So the waveform is like this. So during the switch on period, so we will represent with the D1, we will represent with the DT, and this period will be the D1T. This period will be the D1T. So now, if I draw the VL waveform, that is voltage across inductance. So if I close this switch, what happens? So V1 equal to VL. So V1 equal to VL. So during this period, it will be the V1. So if I open this switch, so what happens? This diode will into the conduction state. I will get the VL as V1 minus V2. So which is the D1T and it is a DT. So if you can able to understand that, that is sufficient to obtain the expression. So this slope will be the V1 by L, and this slope will be the V1 by L, and this slope will be the V1 minus V2 by L. And this is the Imax. Now, here my question is, the power is transferring from the source to the load. How much power is transferring from the source to the next source, second source? So ID into the diode current into V2. So the power will be the, here the power will be the, this diode current into V2, the secondary source voltage. ID into V2 is the power. We need to find the ID value. So we know the V2 value. We need to find the V2 value. So how I can find the? So we know the V2 value. We need to find the ID value. How I can find the ID value? So ID value is nothing but, so ID current will conduct for only this period. This diode will conduct for this period. So how I can find the ID value? So ID equal to so ID average value equal to half into 1 by 2 into Imax into 1 by 2 into Imax into, so what is the value? D1T. So this base will be the D1T, D1 into T divided by T. So how we can find? So I need to find the area of this triangle. So this area, this red color triangle I need to find. So here the height will be the Imax and the width will be the D1T, half into base into height. So we need to find this. How I can find the Imax value? So Imax value, I can take the V1 by L into dt, or else I can take the V1 minus V2 by L into dt. So I need to find the, so here half into Imax value will be the V1 by L into dt, into D1 into T and T will get cancelled into D1. So from this I need to find the ID value. ID value. So to understand the problem, I am explaining clearly each and every step. But if you can understand the concept, you can write directly by observing the waveform. So now I got the ID waveform. But in this I don't know the value of D1. How I can find the D1? So by applying the old second balance to this. So V1 is given as 100 volts and V2 is given as 300 volts. So here V1 is given as 100 volts. V1 is given as 100 volts and V2 is given as 300 volts. Now V1 minus V2 will becomes the minus 200. 100 minus 300. So which is the minus 200 volts. Now I need to find the, so VL value. So I need to find the, now I need to find the, so what I need to find? So I need to find the D1 value by applying the old second balance. I need to find the D1 value. So that is V1 into, that is 100 into D into T. So 100 into D into T, 100 into D into T, minus 200 into D1 into T. So minus 200 into d1 into t. So which is equal to 0. So I don't know the d1 value. Let me find the d1 value. Let me find the d1 value. So d is given as 0.5. So d is given as 0.5. So let us find the d1 value here. So v1 minus v2. So we need to keep the plus sign here. So because vs minus v0 itself negative. So we need to keep the v1 minus v0. So it is minus 200. So but we need to keep the v1 minus v2. So now if I take this, so 100 into 0.5 plus 200 into d1, which is equal to 0. So from this I need to find, so it will be the minus sign only. So my vn minus v0 equal to 200, right? So it will be the minus sign only. So now try to find the d1 value. Try to find the d1 value. How I can find the d1 value? So 100 into 0.5 is 50, right? 50 minus 200 into d1 equal to 0. So d1 equal to 50 by 200. d1 equal to 50 by 200. So which is equal to d1 equal to 50 by 200. 50 by 200. So which is equal to 0.25. I got the d1 as 0.25. Now if I know the d1, if I substitute in this expression, I will get the id waveform, id expression for id. How I can find the id expression? So id expression will be the half into 100 by L. So 100 is the VL. So L is given as 100 microhenry. So 100 by 100 microhenry, 100 by L into dt, which is the turn on time. So d into d is given as 0.5. So d1 is 0.25. d1 is 0.25. So let us check what is the frequency has given. Let us check what is the frequency has given. Is given as 20 kHz. So it is given as 20 kHz. 20 into 10 cube. So 20 into 10 cube. So now if I find this, so I will get the value as 25 amperes. I will get the value as 25 amperes. So we have find the ID average. To find the ID average, we need to find the D1 value. So for that we have used both of these waveforms. Now if I know the ID value, I can find the power easily. So how I can find the power? So P equal to power equal to, how I can find the power? So the power equal to V2 into ID. So what is the V2 value? So 300. So 300 into, so V2 we got the, so value as, so V2 is given as 300. So 300 into 25. So V2 into ID. So ID we got as 3.125. So Imax we got as 25. So it will be the 3.125 guys. It will be the 3.125. Just check once again. It will be the 3.125. So now ID we got as 3.125. So let me find this. So it will be the 300 into 3.125. 300 into 3.125. 300 into 3.125. So 937.5 watts. 937.5 watts. Just calculations. Make sure that calculations are clear. So there is a simple calculations. So let us understand this problem. First we have find that, so whether it is operating in the continuous conduction mode or discontinuous conduction mode. So after that we have drawn the IL waveform and VL waveform. So from the VL waveform we have found the D1 value we have determined. So from the IL waveform, so we have find the ID value. So we got the ID as the 3.125 amperes. So substitute in this, so you'll get the ID as 3.125 amperes. Let me check once again. It will be the 0.5 into 0.25 divided by 4. So yes, 3.125 amperes. It is correct. So it will be the 3.125 amperes. So now if you got the 3.125 amperes is the answer. Let us find power. Power equal to, so V2 into ID. So the power is delivering from the source to the first source to the second source will be the V2 into ID. So which is nothing but 937.5 watts. So the answer will be the 937.5 watts. 937.5 watts. So ID average value will be the, Harish, do you have doubt? So it will be the ID into V2, right? So it is operating in the discontinuous conduction mode, Saloni. So we need to find the V2 into ID because we need to find the output power. So output source power. So VT into ID you need to find for the finding the ID. So we need to use these two waveforms. So try to observe that calculations will be easy. Calculations will be easy. So make sure that calculations will be more clear. So use the calculator in the proper manner. So you'll get the 3.125 as the ID average value and V2 is given as 300. So it will be the 937.5. Answer would be the 937.5. So please check the answer. So answer would be the 9 point. So here answer will be the 937.5 watts. No formula has used. So here no formula has used. So by simply from the basic concepts only we have derived. So we have solved the problem. So try to get the basic concepts, guys. If you understand the basic concept, otherwise try to revise the theoretical concepts too. So if you understand the basic concept, that is more than enough. No need to substitute in any formula. No need to mug up any formula. Harish 239, do you have any doubt? Let us move on to the next problem. So try to find this problem. So which is very easy. So which is continuous conduction mode problem. So try to find a solution for this. In the circuit, L is given as 0.6 millihenry, R equal to 5 ohms, resistance is given as 5 ohms, and the switch is operated at 10 kHz, S is operating at 10 kHz, the duty ratio is given as 60%, capacitor is large enough so the ripple across the it will be negligible as its steady state acquires the voltage of 75 volts. So voltage is given as 75 volts. So Vs is given as 50 volts and V0 is given as 75 volts. Duty cycle is given as 0.6. Now what we need to find? The peak current drawn by the 50 volt source. We need to find the peak current value. Here we need to find the peak current value. How we can draw the peak current value? Let us find. So let us find this one. So here it is, my first question is, in which operating mode this converter is operating? Can anyone answer that? In which operating mode it is operating? Saloni, right? You are right. 937.5 is the right answer. Try to follow the Rashid problems are good. So otherwise Daniel W. Hart one book is there. For DC to DC converter it was the best book. So you can understand clearly Daniel W. Hart. So it will be the power electrons by Daniel W. Hart. So with this problem let us close the session, guys. In which operating mode this converter is operating? Can anyone tell which operating mode this converter is operating? In which operating mode this converter is operating? Suraj, are you there? Be interactive. Continuous conduction mode. So Aicha, you are right. So it is operating in the continuous conduction mode. So how we are saying that? So here it is the buck boost converter because the inductance is common to both source and load. By observing the circuit itself, I can tell that it is a buck boost converter. What is the gain of buck boost converter in continuous conduction mode? V0 of continuous conduction mode, which is equal to Vs input voltage into, that is VDC input voltage into D by 1 minus D. So where D is given as 0.6, so Vs is given as 50 volts. So Vs is given as 50 volts and D is given as 0.6 divided by 0.4. So try to find this. So 50 into 6 by 4. So we are getting the 75 volts, same as given voltage, 75 volts. Now what we need to find here? So it is simple, guys, what we need to find. So when I need to find the source current, So I need to find the source current. Source current here, the source current is equal to switch current. In this case, the source current is equal to the switch current, because they are connected in series, right? Source and switch are connected in series. So the switch current will be the now we need to find the peak value. So if I draw the source current or switch current, source current and switch current both are same in this case. If I draw the source current or switch current, the switch current carries the inductor current only the dt period. The switch will carry the inductor current only the dt period. So now if I draw the switch current, it will be like this. Switch current or the source current, it will be like this. So it will be the I max, and it has the I minimum. So and this ripple will be the delta IL. So what we have to find here for the continuous conduction mode, so what is the I max value? I max equal to IL into IL plus delta IL by 2. So I need to find the IL value as well as delta IL value. So how I can find the IL? So IL equal to as we know that I naught equal to this inductor current flows in the load only during the period of 1 minus d period. So that I naught equal to IL into 1 minus d. Understand this one? So the inductor current flows in the load only during the period of 1 minus d. So that I naught equal to IL into 1 minus d. No need to buy out the formula. By simply observing the circuit, so we can write. So IL equal to I naught by 1 minus d. So how I can find the I naught? So it is the V naught by R. So what is the R value they have given? So R is given as 5 ohms. So V naught is given as 75. 75 divided by 5, which is the I naught. So which is the I naught divided by 1 minus d. So what is the d value here? So 0.6. 1 minus 0.6. 75 divided by 5, which is the I naught divided by 0.4. So 37.5 amperes, which is the 37.5 amperes. So we got the IL value. So now we need to find the delta IL. How I can find the delta IL? So delta IL is nothing but, so I need to know the slope. So Vs by L, the slope will be the Vs by L. So Vs by L into dt is the delta IL. So delta IL equal to, now let us find the delta IL. Delta IL equal to Vs by L into dt. So from this line only you can find delta IL equal to Vs by L into dt. So the Vs value is given as 50 volts, right? The Vs value is given as 50 volts. And what is the L value they have given? So L is given as 0.6 millihenry. So duty cycle, we got the duty cycle as 0.6. Duty cycle is 0.6 divided by T equal to 1 by F we can take. So what is the frequency they have given? So they have given the frequency as 10 kHz. So frequency as 10 kHz. So from this I can find the delta IL. So what is the delta IL here? So 50, so divided by 10k, so 0.6 milli, so it will be the 5 amperes. Now, so I need to write the Imax. Imax equal to IL plus delta IL by 2. So we got the IL as 37.5. IL equal to 37.5 plus, so it will be the 5 amperes. It will be the 5 by 2. So which is equal to 40 amperes. So the maximum value of the source current will be the 40 amperes. Answer will be the 40 amperes. Answer is 40 amperes. Saloni, the V naught is already given, it is 75 volts. Right? So try to find. So I maximum value. So I max we got as a 40 amperes. Just check the answer, guys. So I max you will get the 40 amperes. I max will get the 40 amperes. So I will share the problems of this one is in GATE Conqueror channel. So GATE Conqueror Telegram channel. So previous session and this session also I will share in the GATE Conqueror channel. Everyone got the answer? Everyone got the answer? If everyone got the answer, let us move to the next problem. So with that problem, let us close the session. So if everyone got the answer, let us move to the next problem. Let us move to the next problem. Let us move to the next problem. So try to find the answer for this, which is very easy question. Saloni, 40 amperes is the right answer. Suraj, right. Let us move to the next problem. Harish, 40 is right answer, right. So which is also very easy question, guys. So which is also very easy question. Let me explain the problem. So after that you can solve like anything. So it was given as buck converter in the problem itself. So it was specified as buck converter. So feeding the variable resistive load, right? So the load is variable resistance. The load is variable resistance, and the switching frequency is given as 100 kHz. The switching frequency is given as 100 kHz. The switching frequency is given as 100 kHz, and the duty ratio is given as 0.6. Duty ratio is given as 0.6. So the output voltage V0 is 36 volts. The output voltage V0 is given as 36 volts. V0 is given as 36 volts. And we need to find the value of R that will make the inductive current is just continuous. So that means this converter should operate in the boundary conduction mode. This converter should operate in the boundary conduction mode. This converter should operate in the boundary conduction mode. So try to find the answer. So it is just continuous in the sense it is operating in the boundary condition. It is operating in the boundary condition. So try to find the answer for this one. It is operating in the boundary conduction mode. So for the boundary conduction mode, so we know the condition. What is the condition for the buck converter? 2L by RT equal to 1 minus D. 2L by RT equal to 1 minus D. So here we need to find the critical resistance. In this question, they are asking that, so for which resistance, for which value of the resistance, this converter will operate as just continuous. Just continuous. Just continuous in the sense, it should operate in the boundary conduction mode. So I should vary the resistance in such a way that it should operate in the boundary conduction mode. From this, R critical value we need to find. So where R equal to R critical. So how I can find the R critical? So 2L into F 1 by T. Let me replace that 1 by T equal to F. 2LF divided by 1 minus D. 1 minus D. So we can find the R critical easily. So 2 into L is given as 5 millihenry. L is given as 5 millihenry. 5 into 10 power minus 3. So frequency is given as 100 kHz. Frequency is given as 100 kHz. Divided by 1 minus D, 1 minus 0.6, 1 minus 0.6. So try to find the answer for this one. So try to find the answer for this one. Try to find the answer for this one. So 2LF divided by 1 minus D. 1 minus D. So what is the answer? 25. Let me see. 2 into 5 into 100 divided by 0.4. So which is the 2500 ohms. So we should mention in ohms which will be the 2500 ohms. So the answer is 2500 ohms. R critical is 2500 ohms. 2500 ohms. For example, if they asked for the buck boost converter, so for the example, if they asked for the boost converter, we need to use the relation as 2L by RT equal to D into 1 minus D whole square. If it is buck boost converter, 2L by RT equal to 1 minus D whole square. So simple relations. Harish 239, 2.5K is the right answer, but don't confuse here. When you answer the question, so observe here, the value of R in ohms. They are asking in ohms, so that when you write the answer, it should be in ohms. So 2.5K is the right answer, but so don't write the 2.5K as the answer because they are asking the answer in ohms. So it will be the 2500 ohms. Right. So this is all for today. In the remaining 2 sessions also, let us solve some of the problems, some of good problems, conceptual problems. So let me cover some of the good problems in discontinuous mode as well as continuous conduction mode in the boundary conduction mode, because these topics are much important. You open the previous question papers of last 10 years. So observe that. So every question, so almost all, if it is 8 to 10 marks is a range, 5 marks you will get from the DC to DC converters. Definitely. So observe the previous question papers, you will get the 5 marks from the DC to DC converter, and that too it is from the either continuous conduction mode, discontinuous conduction mode, or the boundary conduction mode. So try to solve the problems from the basic concepts. So if you solve from the basic concept, no need to remember and no need to mug up the formulas and all. Suraj Padi, how to check the boundary conditions means, so either there should be 3 conditions, there should be 3 possibilities are there. There are 3 possibilities are there to check the boundary condition. So to check the boundary condition, so one condition will be the IL equal to delta IL by 2. The basic condition, all these conditions are derived from this condition. When average inductor voltage is equal to half of the ripple current, when average inductor current is equal to the half of the ripple current, so we can say that it is a boundary conduction mode. So this is the first condition. So because in a boundary conduction mode, I minimum equal to 0. I minimum equal to 0. Or else we can verify with this. L should be greater than, so L should be greater than L critical value. So L should be greater than L critical. The critical value of inductance should be greater than L critical. So in case of buck converter, so these are all the conditions are there. 2L by RT equal to 1 minus D for the buck converter. So this condition also derived from the basic condition. So it is for the buck converter. 2L by RT equal to D into 1 minus D whole square for the buck boost converter. Sorry, it will be the boost converter. So for the boost converter, so 2L by RT equal to 1 minus D whole square. So this is the condition for the buck boost converter. So apply this data according to the given data. So apply these formulas and all. So apply this concept. So according to the data given. In the problem they have mentioned the L value, R value and T value and duty cycle. So you can find the boundary conduction mode from this. So in the problem they have mentioned that, so L value, inductance, only inductance value, find the L critical value. So from this you can compare that when L is greater than L critical, so you will get the things. So or else from the basic concepts, if you know the basic concepts, so find from this one. So find from this. So this is all for today, guys. If you have any doubt, you can ask. From tomorrow 9 a.m. I have a special class. Tomorrow at 9 a.m. I have the special class on single phase voltage source inverters, analysis of the single phase voltage source inverters, analysis of the single phase voltage source inverters, so on. I have the special class on 9 a.m. So this is all for today. So thank you all for this session. Thank you all for attending the session. So please do subscribe and share the content. So and like the content. So if you have doubts, you can ask at any time. So thank you so much, guys. So thank you all for joining the session.